Hello guys, welcome once more to another video in our YouTube channel. So in this video we look at June 2019 further math paper theory equation 2, equation from oscillatory motion. Now the equation was divided into two parts. The first part we were given the equation of motion of a body and we were asked to show that the displacement of the body at any time t is equal to this, and we find a period. And in the second question we're being told that a body performs simple harmonic motion with amplitude of 2 meters and the period of oscillation was given. Now we have to find the time taken for the particle to move from P directly to Q, where P and Q were on the either side of the center of oscillation. So this diagram was not given. This is just a diagram that I drew to use to explain. So without wasting much of your time, let's get started. Alright, before we start, if you're new to this channel, make sure you like the video, you share the video with your friends, and you also subscribe to the channel. After subscribing, you turn on your notifications so that when other videos are uploaded, you'll be notified to come and watch. If you have any difficulty while you comprehend the explanations, make sure you indicate that in the comment section. Now, to be able to solve this first part of this question, we must have a pre-knowledge of second order differential equations, which is being taught in pure mathematics, sorry. So if you don't have that if you don't have that pre-knowledge, it becomes very difficult for you to solve this question. So having in mind that you have that pre-knowledge, I'll just dive straight away into the solution of this question. If you don't have the pre-knowledge about that topic, you indicate in a comment section. The number of indications will motivate me to be able to do a video on second order differential equations. All right, so let me read this question and then we analyze together. The equation of motion of a particle moving in a straight line OX is given by this. X is the displacement of the particle from O at time t. Initially the particle is at O, moving with speed √3 meters per second. Show that the displacement of the particle is x equal to ae to the negative t cos nt plus epsilon, stating the values of a, n, and epsilon. Then find the period of oscillation. All right. First of all, to show this equation here is just the general solution to this second order differential equation. All right, but after doing that, we need to apply the initial conditions to find the values of a, n, and epsilon. So how do I get a general solution of such a differential equation? First, I start by finding my auxiliary equation. Now this auxiliary equation is an equation in terms of a certain parameter, which is going to be quadratic because it is a second order differential equation. So all I need to do is I replace the squared x by dt squared with a parameter squared. I replace dx by dt with a parameter to the power 1, and I replace x with a parameter to the power 0. So the parameter to the power 0 is 1, that's why you're just left with 4, and I also include all the constants in front of the parameter. So my auxiliary equation is 3m squared plus 6m plus 4 equal to 0. Just saying it so that for those of you who don't know how to solve maybe second order differential equations, you can already get a clue about that. So this is my auxiliary equation, and I need to solve this quadratic equation to get the values of m. So I'm going to use a formula method, and m will give me negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Now when I do b squared minus 4ac, we are going to have 36 minus 48, which is negative 12, and the square root of negative 12 will give us a complex number, and that complex number is I times the square root of 12. Now I'm going to separate this fraction into two different fractions. I will take negative 6 divided by 6, then plus or minus I root 12 divided by 6. Now, knowing fully well that root 12 is the same as 2 root 3 because it is root 4 times root 3, and root 4 is equal to 2, so it means that m will be negative 6 over 6 plus or minus I 2 root 3 on 6. Negative 6 over 6 is negative 1. 2 root 3 on 6 is root 3 over 3, because 2 here 1 time, 2 here 3 times. So it means that my values of m, we have -1 plus I root 3 on 3, as well as -1 minus I root 3 on 3. So this is a complex solution. All right, so when the roots are complex, then the motion is oscillatory. Yes, when the roots are complex, the motion is oscillatory. Now when you're oscillatory, you could be either simple harmonic or you are damped harmonic. Okay, but in this case, since the real part of m is not 0, then it is damped harmonic. The real part is -1. Anyways, we are concerned with getting the general equation. So whenever the roots are complex, if the roots are in the form a plus or minus ib, then the general solution is of this form: capital A e to the at cosine of bt plus epsilon, where this small a here is the real part of the root and small b is the imaginary part of the root. If you don't want to write it this way, you could also put in the form sine re to the at, the sine of bt plus epsilon, or you put in the form cosine sine e to the at times a sine bt plus b cos bt, in any form of your choice. But according to what I have here, I need to just put it in the form a e to the at cos bt plus epsilon. All right, so in this case, you realize that our a is basically the real part of the root, and a here will be -1, while b is the imaginary part of the root, which is root 3 on 3. It therefore means that my x will be equal to a e to the -1t, which is just -t, the cosine of root 3 on 3t plus epsilon. Now you see that we can already deduce that the value of n is equal to root 3 over 3. Now we need to find the value of a and the value of epsilon. So how do I find the value of a and the value of epsilon? I need to use my initial conditions. My initial condition says that initially the particle is at the origin and it is also moving with a speed of root 3 meters per second. So for me to apply this initial condition, I start by getting the velocity. All right, so velocity is gotten by differentiating my displacement. So velocity is dx by dt. So dx by dt, I'll need to differentiate this, and to differentiate this I need to use the product rule. I'm going to keep cosine of root 3t plus epsilon constant, and I differentiate e to the -t. I'm going to have negative e to the -t, but since a is also a constant, it stays there. Now I need to add it to, this time around I am going to keep a e to the -t constant, then I differentiate the cosine of root 3 on 3t plus epsilon. When you differentiate the cosine of this, you first of all need to differentiate the angle. When you differentiate the angle, you get root 3 on 3. When you differentiate cos, you have negative sign, that's why you have a negative sign here. Then you multiply it with the sine of root 3 on 3t plus epsilon. So this is just differentiation via product rule. Now this portion in red is my original displacement. All right, you see they are equivalent. Now my initial condition is saying that when time is 0, the displacement is 0, because you were at the origin initially, and the velocity or the speed is root 3 meters per second. So let's begin with applying. When time is 0, the speed is root 3 meters per second. It means that root 3 will be equal to, I come here and I replace time with 0. Once I replace time with 0, you realize that this portion here is going to just give us 0, because this portion is the displacement, and when time is 0, the displacement is 0, so everything here becomes 0. Now when everything here becomes 0, what do we have? We have negative root 3 over 3. We are going to have here negative root 3 over 3 a e to the negative. Now I need to replace t here with 0. Once I replace t with 0, e to the power 0 is 1, so we are just going to have here negative root 3 over 3a. Now I replace t with 0 here, so root 3 over 3t becomes 0. Then we are left with 0 plus epsilon, which is epsilon. It therefore means that my root 3, which is my speed at t equal to 0, is basically negative root 3 over 3 a sine epsilon. Root 3 cancels, and then at the end of the day we have a sine epsilon to be equal to negative root 3. Now let's also apply the initial condition that says that when t is equal to 0, the displacement is equal to 0, because you were at the origin initially. So the displacement being equal to 0, it just means that I just need to replace t to be 0 here, everything here is going to give us 1. Then we are going to have a. If I replace t with 0, what will be inside here will be epsilon. So at the end of the day, we have x, which is 0, to be equal to a times the cosine of epsilon. Alright, so from here it just means that the cosine of epsilon is equal to 0, because we can divide both sides by a. A is not 0, a is bigger than 0 or less than 0, depending on what the equation said. But the equation did not tell us that a is either bigger than 0 or less than 0, so we can choose, it could be either positive or negative, there is no problem. So but we know that a is a maximum displacement, that's the amplitude, and displacement can be negative. So we have cos epsilon to be 0, right? Now if cos epsilon is 0, it means that epsilon is cos inverse of 0. That's just the principal value. But now there is something very peculiar about this. If we decide to make a to be positive, right? Now look at this. If a is positive, it therefore means that this sign of epsilon has to be negative, so that when you multiply the two quantities here, the result is negative. So if a is positive and epsilon, now a is positive, we are choosing that a is positive. You could also maybe allow your a to be negative, but I want a to be positive. All right, so if a is positive, then the sign of epsilon has to be negative, and for the sign of epsilon to be negative, and you are in the first quadrant, or I don't know, epsilon has to be negative. Okay, so if cos epsilon is 0, epsilon will be chosen as negative pi over 2. Cos inverse of 0 is pi over 2, that's the principal value, 90 degrees, because cos 90 is 0. But also cos of negative 90 is also 0. So I am choosing negative 90 so that the sign of it will be negative. And when I replace epsilon here with negative 90, sine negative 90 is negative 1. So the left hand side here becomes negative a, and the right hand side is negative 3. The two negative signs cancel, and we get a to be 3. If you allow epsilon to be pi over 2, there is no problem. Alright, if you allow epsilon to be cos inverse of 0, pi over 2, there is no problem. Your a will be negative, and you are still perfectly correct. So you are just going to have x to be if I choose epsilon to be negative, then my x will be equal to 3 e to the t cosine of root 3 on 3t, we are replacing here. Then if I'm choosing epsilon to be negative, then this becomes minus pi over 2. But if my epsilon is positive, pi over 2, it therefore means that my a here will be negative. So x will be equal to negative 3 e to the t, the cosine of all of this, then plus pi over 2. So it all depends on your choice. Any choice, you are still correct. So last part, we need to find the period of oscillation. Period is 2 pi on omega. Omega is the angular velocity, and it is basically the imaginary part of my complex number m. That is the imaginary part of my solution. So omega here is root 3 over 3. Alright, so my period is 2 pi divided by root 3 over 3. Give me your answer in the comment section after simplifying. Okay, so we are done with the first part of this question, and let's move on to the second part of the equation. Okay, here is the second part of the equation, and it reads: a particle performs simple harmonic motion with center O and amplitude 2 meters. The period of oscillation is pi seconds. P and Q are 2 points which lie at a distance of root 3 on either side of O. Find the time taken by the particle to move directly from P to Q. So first of all, we are going to draw the diagram, alright, and I'm going to explain from there. So you have to be very vigilant, because this question is kind of very technical. I am going to use 2 different methods, and you choose the method to analyze. You choose the method that you want to use, depending on how much you understood that method. But anyways, I'll try my best to simplify each of those methods to the least. Okay, so first of all, what do I have? First of all, we have that a particle is performing simple harmonic motion with center O and amplitude 2 meters. So I will start by drawing first of all draw my center. Alright, this is kind of my vertical, it is O. Then it is performing simple harmonic motion with center O and an amplitude of 2 meters. So I can just consider that, okay, this particle is kind of a simple pendulum. though you can also consider that it is a string, but I just took a more simplified version, a simple pendulum. So if you consider the particle is a simple pendulum, initially it is at this position and then it is kind of swinging, right? It is swinging, so it is moving from this position to a certain position here, going back and all the rest. So initially it is at a point A, and then now after a certain time period it is at a point B, all right, and then it now goes back. So it moves, it performs simple harmonic motion between a point A and B, all right. Now what happens is that the amplitude is a maximum displacement, okay, and a maximum displacement is just a distance that is separating the horizontal distance separating the center of oscillation and the point A, because if you pull it to this position where the laser is, then that maximum displacement is going to be there, but if you pull it to this position, then that is where the maximum displacement is going to be. So the distance from the origin, that's from the center to O to A, is 2 meters, and also the distance to B is 2 meters, but the displacement from O to B is -2 because B is on the left hand side, is to the left of the center, okay. But since you are dealing with distance, I just put 2 meters and 2 meters. But when we are going to be analyzing, we'll talk about the displacement, where the displacement at B will be -2 because it is to the left of my center. Okay, now what happens is that since this particle is performing simple harmonic motion between these 2 points, in the path of the simple harmonic motion, there are 2 other points in the path, all right, and the 2 other points are such that we have this point here, which is P, and we have this other point, which is Q. Now P is at a distance of √3 from the center, while Q is also at a distance of √3 from the center, but Q is at a displacement of -√3 because it is to the left. Distance is positive, but displacement could be negative, all right. Displacement is a vector quantity, distance is a scalar quantity. So the distance between the point Q and the center is √3, and the distance between the point P and the center is √3. Now the displacement of the point P from the center is positive, while the displacement of the point Q from the center is negative because Q is to the left of the center, assuming that all displacements to the right are positive while to the left are negative. So the particle is kind of performing simple harmonic motion between the 2 points. So maybe we have something like this, all right, performing simple harmonic motion between the 2 points. So that is it. So it's performing simple harmonic motion between A and B, and then we need to find the time taken for the particle to move from P right up to Q, from P directly to Q. Okay, so first of all, we are going to start by finding the displacement of this particle at any time. So since it is performing simple harmonic motion, then the displacement will be in the form r cos omega t, because I released it from a certain height, all right. If it was released from the origin, then the displacement will be r sine omega t. R is the maximum displacement. In this case it is 2, while omega is the angular velocity. Angular velocity omega is the same as 2 pi over period, and the period is pi, so the angular velocity is 2 pi over pi, which is 2. So my displacement will be 2 cos 2t. Now let us plot a graph of the displacement against time. So displacement against time graph of my particle, first of all, I need to my period is pi, right? It is performing simple harmonic motion between 2 points. The maximum displacement is 2 meters and the minimum displacement is -2 meters. You see, since we are plotting a graph of displacement, you realize that the displacement can be negative. So, but for a particular time which is positive, the displacement could be negative. Okay, now it's going to be we're drawing a graph of arrow of x equal to 2 cos 2t. All right, so we have to analyze so that we try to put the values of time on the horizontal axis. So I start by solving when is a displacement 0, that is, when is a displacement 0, at which time is a displacement 0, at which time is a displacement on the horizontal axis. So if the displacement is 0, which means that you are actually at the center, because the displacement is actually the displacement from the center. So when the displacement is 0, it means that 2 cos 2t is 0. It means that cos 2t will be 0. And if cos 2t is 0, then 2t will be 2n pi plus or minus cos inverse of 0. That's the general solution. Cos inverse of 0 is 90, which is pi on 2. So 2t will be 2n pi plus or minus pi on 2. So what will be t? T will be n pi when we divide all through by 2, n pi plus or minus pi on 4. When n is equal to 0, t is plus or minus pi on 4. But since I'm dealing just with the positive t axis, then my t will be positive pi on 4 only. So I begin with pi on 4. So this is the first instant when the displacement will be 0. So when you move from A and you go to O, the time taken from the point A to the point O is basically pi divided by 4 seconds. All right, now when you move from O, you now need to move to B before you come back to before you need to move to B before you come back to O and go back to A again. So the period is basically the time taken to complete one oscillation, meaning the time taken to move from A to B and back to A. That is the time taken to complete one oscillation. That's a period. But anyways, when do you hit the horizontal again? If n is equal to 1, we are going to have t to be pi plus pi on 4 or pi minus pi on 4. Pi plus pi on 4 is 5 pi on 4. It's already above the period, so we just ignore it, because I just want to analyze for one complete oscillation. Pi minus pi on 4 is 3 pi on 4, so 3 pi on 4 is here. Now my period is pi. So let us draw the graph. So what happens is that the guy moves from, you move from the point A. All right, again I'll explain. You move from A. Now at the point A, the time is 0 and your displacement is 2 meters and it is positive. So it therefore means that this is what happens. You move from A, means that this is a point A. All right, you move from A, then you go to the origin. At the origin, the time traveled, the time taken is pi on 4. Now from the origin you go to B, okay, then from B you go back to the origin, and then from the origin again you go back to A. You see, this is one oscillation. Now this is a point B here, all right, where you are at a distance of -2. The distance, sorry, you're at a distance of 2, but the displacement is -2 because you are below, all right, or you are to the left of the center. Now so here is my period. So that is for one oscillation. So the time taken to complete one oscillation is my period, pi. All right, so this is a graph of the displacement against the time. This is the first method I'm using. All right, the second method is very short, but I want to really analyze this using the first method, so that you actually get to understand what happens during simple harmonic motion and how all these graphs came about. Okay, now objective of the equation, we need to find the time taken to move from P to Q. Now let us indicate P and Q on our diagram. Okay, so where will P be? First of all, you are moving from, P is in between A and O. All right, this is A, here is A. Now if that is A, then this is B here, and then this is A again, because you are oscillating, so you're passing through A and B so many times. Now P is going to be around here because P is in between A and O. All right, and then Q now is in between O because this is O here. Okay, this is O. When you are on the horizontal axis, then your displacement is 0. All right, now so Q is going to be around here also. Wait, let me try to I've made a mistake. I have to redraw back. Okay, now Q is around here. So this is Q, here is Q, here is P. Okay, so the objective is to find the time taken to move from P directly to Q. Okay, but you see that to move from P to Q, you will move from P to O, then you will now move from O to Q. That's what that is how we have to see that. Okay, so first of all, let us find the time taken to move from P to O, and then we just multiply by 2 because P is at the same distance from O as Q is. They are at the distance of √3. So the time taken from P to O will be the same as the time taken from O to Q because you are covering the same distance. Okay, so if we find the time taken from P to O, we just multiply by 2. But at this point P, what is happening? So first of all, let's try to analyze it this way. The time taken to move from P to O, I can call it TP. Now we need to find that time taken. So first of all, at T equal to T1, what is T1? This is my T1. T1 is this value here. This is T1. Okay. T1 is the time taken to move from A right up till P. That is T1. We need to find T1. So what is the value of X? What is the value of the displacement? When the time is T1, you are at P. Okay, you are at P. And when you are at P, the displacement from O is basically √3, right? Because here is it. The distance separating P and O is √3. So when you are at T1, the displacement is √3 meters. So it therefore means that I just need to equate my displacement, which is 2 cos 2 T1, because I'll replace the time with T1. So I have √3, which is my displacement, to be equal to 2 cos 2 T1. Okay. Now, this T1 actually is the time taken. In fact, anyways, I'm going to explain later. √3 will be equal to 2 cos 2 T1. Right? Now, when √3 is equal to 2 cos 2 T1, we now need to find the value of T1. We first of all divide both sides by 2 to get cos 2 T1 to be equal to √3 on 2. Then we look for the because everything is occurring in the first quadrant. So we are not going to find general solution. We'll just be getting the principal value. So 2 T1 will be cos inverse of √3 on 2. Cos inverse of √3 on 2 is basically 30 degrees, which is pi on 6. So T1 is equal to pi divided by 12. That is T1, pi divided by 12. So this T1 here, alright, is pi divided by 12. Okay, so T1 being pi divided by 12, do we need to find T1? No, we need to find TP. TP is the time taken to move from P to O, alright? You realize that if I take the time taken to move from A to P plus the time taken to move from P to O, I will get the time taken to move from A to O. So to move from A to P, the time taken is T1. Now, to move from P to O, the time taken is our TP, which we are actually finding. So the time taken to move from A to O, we know that it is pi over 4. Okay, because that is A from A to O. At O, you are the origin, you are the center of oscillation. So that time taken is just the value here, which we got as pi divided by 4. So basically, the time taken to move from A to O, from A to P, plus the time taken to move from P to O, which is TP, will be equal to pi over 4. So what is TP? Is pi over 4 minus pi over 12, because we have found T1 as pi over 12. When we do that difference, you get pi over 6. But what is the total time we are looking for? The total time we are looking for is the time taken to move from P to Q. So the time taken to move from P to Q is basically 2 times the time taken to move from P to O, because P and O are at the same distance. P and Q are at the same distance from O. So the time taken to move from O to Q is TQ, which is equal to TP. It therefore means that the time taken to move from P to Q is TP plus TQ, which is TP plus TP, because our TQ is also TP. So when we add the two, we get 2 times TP. So at the end of the day, we multiply pi on 6 with 2, and we get pi divided by 3 seconds. So that is it. So this analysis is, I don't know, it's a little bit strange, but it is also very, very important for you to understand what happens during simple harmonic motion, what happens to the particle, how the equation of motion came about, how to analyze the motion on the graph. Okay, now using the famous method, which is very direct, we use the fact that the velocity, we are going to use integration. So the velocity v is equal to r the square root of omega squared minus x squared, where r is the amplitude, omega is the angular velocity, x is the displacement at any time t, and v is the velocity at any time t. Now our arrow is our displacement, our amplitude is 2, omega is also 2, all right, because omega is 2 pi on pi since period is pi, and our x, our v is dx by dt. So dx by dt is 2 times the square root of 4 minus x squared. Now this is a first order differential equation, so we have to separate variables and integrate. So separating variables means anything in terms of x on one side, anything in terms of t on the other side. Now we can integrate. Now I am integrating x, my displacement, from where to where? I'm integrating from p to q. So I'm going to integrate from negative root 3 to root 3, all right? And we are taking from negative root 3 to root 3. We are integrating from q to from the smallest to the biggest. The smallest is negative root 3 and the biggest is root 3. We are saying negative root 3 because x is displacement, all right? It could be negative, and q is on the left. Now what about the time? When the displacement is negative root 3, the time is 0, and when the displacement is root 3, the time is t, and we need to find this t, because this t is the time taken to move from negative root 3 to root 3. Now clearly, integrating from negative root 3 to root 3 is the same as integrating from 0 to root 3 and multiplying by 2, because this function here is an even function. That's a property. Now when I integrate this, standardly I get sine inverse of x over 2. Now from 0 to root 3, the 2's are going to cancel, so this 2 we cancel with this 2, and then we just integrate the left hand side. We get sine inverse of x on 2 from 0 to root 3. When I integrate dt, I get t. When I replace with t, I still get the t. So my t will be equal to sine inverse of x over 2 from 0 to root 3. Now I replace x with root 3 and x with 0. When I replace x with 0, the lower bound becomes 0, so we don't care about it. Now we need to just replace the upper bound with root 3, and we realize that t will be sine inverse of root 3 on 3. Sine inverse of root 3 on 3 is 60 degrees, which is pi divided by 3 seconds. So it means that the two methods are okay. So the time taken to move from p directly to q is pi divided by 3 seconds. So any method of your choice is acceptable by the GC board. Thank you guys for watching. If you love the video, give the video a like. If you have a question, you indicate in the comment section. If there is any worry, indicate in the comment section. If you are not subscribed, make sure you subscribe to the channel and you share the video with your friends at the end. See you guys in the next video.